Okay, welcome back. You should be on the trapezoid page now, which is page 21. So trapezoids, I think, are a little bit easier than kites. So let's go ahead and define a trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. A quadrilateral with exactly one pair. A quadrilateral with exactly one pair of parallel sides. And you can clearly tell in quadrilaterals which ones are parallel. So in my picture I'm giving you here, the top and bottom are parallel. Okay? The left and right will never be parallel, or else you would have a parallelogram. So there are some other terms that go with trapezoids. The parallel sides are called the bases. So I'm going to write the word base next to each parallel side. The sides that are not parallel are called legs. So leg on either side. Also, we've got a couple of pairs of angles. So along each base here, of course, we have an angle on either side and an angle on either side. These are called the base angles. So that angle along with that angle are called base angles. They are the angles along the bases. We have another set right here as well. So I'm going to write base angles. Now we would call the two along the legs the non-base angles because they are not on the same base. So they have to be along the same base to be called base angles. Okay, so there are some properties. So let's make a list similar to what we did with kites. Okay, so one of the properties of a trapezoid is that these two non-base angles are supplementary. And if you think about it, you have a set of parallel lines cut by this transversal, and therefore these are same side interior. So I'm going to write non-base, let's reword that. Consecutive non-base angles are supplementary. Consecutive non-base angles are supplementary. They add up to 180. And that's the only property of all trapezoids. Now, if we have an isosceles trapezoid, we have more properties. So I'm going to draw myself another picture right here. In order to have an isosceles trapezoid, so there's a trapezoid. In order to be isosceles, the legs are equal. So let's add another title here for isosceles trapezoid. So we've got three items here. Number one, I just said the legs are congruent. Okay. Secondly, not only are your legs congruent, the base angles are congruent. So I can put an arc right here along the top base and then a double arc along the bottom base. So I'm going to say base angles congruent. Now, of course, all four are not congruent to each other. And then if we added diagonals here within our isosceles triangle, those would be congruent as well. So diagonals are congruent. So if it's not an isosceles triangle, the only property you know is that these consecutive non-base angles add up to 180. So there's not a whole lot going on in trapezoids unless it's isosceles. So let's do number one, or number 5 I should say right here. Find the measure of angle A. So the key here is to identify the bases. So CD and BA are the parallel sides. When my legs are congruent here, that is isosceles. So angle A right here is congruent to another angle. It's congruent to angle B along the base. So angle C is congruent to angle D. So if C and D are both 100, these two have to add up to 180. So I know that B is 80, which makes angle A 80 degrees. So I can kind of work my way around my shape. Okay. All right, you try that down here on number 6. So go ahead and pause the video and work, and then come back and check. Okay, so you should have found that the measure of angle F right here is 131 degrees. This is isosceles, so I know that this one over here is 49, and then F is supplementary to E, so it's 131 degrees. Okay, next one over here, number 7. JN here is 10.6. NL is 14.8. I want to know KM. Well, it is isosceles. I see these marks. So that means that JL is equal to KM. So all I need to do is calculate the length of JL by adding those together. So 10.6 plus 14.8 is 25.4. So that is going to be my length on KM. So 25.4. Okay, let's do this one down here. Find the value of A so that PQRS is isosceles. So in order to be isosceles, the legs would be equal. And if they were equal, I know that these base angles are congruent. So if I set those equal to each other and solve for A, that would give me the value as if it was isosceles. So A squared plus 27 is equal to 2A squared minus 54. So if I solve that, I can take away A squared from both sides. So that would give me just 1A squared. And then I can add 54. So that would give me 81. And when I square root 81, I get 9. But I do want to point out one thing. I also get negative 9, because mathematically that works. So technically speaking, I could get 9 or negative 9. Or if you remember, we talked before about, we could write that as plus or minus 9. So keep in mind, you do have that negative value when you work through that square root. Okay, all right, let's see. I think what I want to do is skip on down to mid-segment here. So there's one more idea with a mid-segment. You might remember when we studied triangles, we studied the mid-segment of a triangle, and it looked like this. It had a segment that intersected at the midpoint, and remember, it was half the value of the parallel side. So if that was 10, then that was 5. And then remember, we could draw like 2 other ones, and you had that mid-segment triangle. You have the same idea on a trapezoid. The mid-segment is going to intersect at the midpoint of the legs, so equal on either side. And so instead of with a triangle where you only had 2 pieces to compare, on a trapezoid you have a top and a bottom. So what we're going to do is we're going to average the top and bottom. So the way the formula is set up, if you take the top segment and add it to the bottom segment and then take half of it, that would be the length of your mid-segment. So for example, if this was 4 and that was 8, well, my mid-segment would be 6, because I could do 4 plus 8, and if I take half of it or divide it by 2, I would get 6. Or you could kind of count. You could say, well, the difference between 4 and 8 is 4 units. And so that means there's got to be 2 units above 4 and 2 units below 8. So there's a couple ways to look at that. But basically, you're going to add the 2 parallel sides and divide by 2. Okay. Oops, let me find my last page here. I lost it. Okay. All right. Let's finish this up here. Number 11. Is that where I'm at? Okay. Okay, number 11. I want to find the length of EF. Now, when I look at this, I know it's the mid-segment. And I know that because I see midpoint marks here. So in order to get the mid-segment, it's the average of the top and bottom. So I want to take 13.5 plus 8 and figure out what that is, and then divide by 2. So 13.5 plus 8 is 21.5 divided by 2. So my mid-segment is 10.75. Okay? Now, the other side of it is when you have the middle, but you don't have either end. So what I want to do here, there's a couple ways to view this. But if I could look at the distance between 16.5 and 25, I could apply that same distance between 16.5 and x. So if I look at 25 minus 16.5, That distance is 8.5. So in order for 16.5 to be the midpoint, if 25 is 8.5 units above 16.5, I need to figure out, well, what's 8.5 units below 16.5? So I want to really do 16.5 minus 8.5. And I get 8. So, and I could always check it. I should be able to do the top and bottom added together and divide by 2. So 25 plus 8 is, not times, 25 plus 8 is 33, divided by 2 is 16.5. So I have correctly calculated that. Okay, so what I'd like you all to do now is I would like you to work on the following assignment. Okay. Let me check one more place here. It's going to be in your textbook. And you're going to be working on page 444. And I want you to look at numbers 4 through 42 even. Oops. Page 444, 4 to 42 even. And I want you to skip 2 problems. I want you to skip number 26 and number 38. Okay, so go ahead and stop the video, grab your book or iPad, you might want some graph paper, and get started, and we will check this in class on the next day.